Hey Chemsters, this is Mrs. Vandeloy bringing you another Chemster video, again for section 7.3. This section is percent composition and chemical formulas. So once again, you're going to need your calculator and a periodic table every day for this entire chapter. So if you don't already have it out, get it out. So our purpose is to determine percent composition given its formula or mass of each component element of a sample. If I gave you maybe a little baggie of M&Ms, wouldn't that be wonderful if I gave everyone a little fun-sized thing of M&Ms? And I asked you to open them up and determine the percent, let's say red. I'm just, picking a color there. How would you go about determining percent red in your baggie of M&Ms? Why don't you talk to your partner? Well, maybe not if they're not listening at the same time you are. But anyway, you should have been talking at least to yourself in your head. How would you have done that? Would you have taken the number of red divided by the entire number of M&Ms in your container or in your packet? And the answer would be yes. That's probably what you would have already done. That would make sense. If I asked you, what is the percent of girls in the classroom, what would you do? Would you take the number of girls divided by the total number of people in the classroom and come up with a percentage? Hopefully you know how to do that. And really what we are doing today is very, very similar to find the percent composition. What we do, and you're going to hear me say this a lot, we're going to take the part over the whole. So when we found the percent red, we took the part that was red divided by the total number of M&Ms in the little packet. If I found the percent girls, we found how many girls over the total number of people in the classroom. It's part over whole. And when we find percent composition of a chemical formula, it is really the same thing. You're finding the part that you're looking for over the whole. Well, in this case, what is the whole? The whole is the molar mass of that particular formula, that particular compound. So for the case of carbon dioxide, let me scroll down a little bit. For the case of carbon dioxide, what is the whole? What is the molar mass of carbon dioxide? Why don't you pause this and figure that out? Okay, did you find this as your answer? So that molar mass is the whole, it's a total. So if I want to find percent percent carbon in carbon dioxide, I take the part that's carbon. Well, how many carbon atoms do I have in carbon dioxide? I only have one. Oops, well, okay, I'll put that anyway. I only have one. Okay. And so it's just 12.01 grams. What about the whole? What is the whole? That's your 44.01. And what we typically do is then multiply everything by 100%. So this is going to be a decimal. So then multiply that by 100%. Go ahead and calculate. What's 12.01 divided by 44.01 times 100? Did you get, 27.3. What I want to show you though, notice what happens here. We have, here we go, grams. Grams are going to do what? Oops, I thought they were going to cancel out for me. Grams are going to cancel out. So grams divided by grams is no unit, so the only unit left here is percent. So that's what happened to our units. Always look at your units, there we go, and determine, how we're going to go about doing that. So the grams cancel out, percent is the only unit left, so it's 27.3%. So let's look at percent oxygen. This is a little bit different, isn't it? Because how many oxygen atoms do we have in one molecule of carbon dioxide? Well, hopefully you realize that there are 2 atoms of oxygen. So what am I going to do to the number 16? I'm going to multiply that by 2. You have to include all the oxygen. And folks, I've been teaching chemistry for a very, very long time. You probably know that. This is probably where the most number of people are going to make boo-boos, is that they forget to multiply, like, how many total oxygens do you have. They'll just put 16 over 44, and that won't be right. So here is 2 times 16 divided by 44. And once again, we're going to multiply it by 100%. What happens again to our grams? Our grams cancels out. What's the only unit left? It is percent. So we end up with a percentage. And this is what I get. The next question is, so what do they add up to? Well, what does 27.3 plus 72.7 add up to? What do you notice? It's 100. And doesn't that make sense? Because if I were to go back and ask, okay, what's the percentage of boys in the room right now? What do you think the percentage of girls and the percentage of boys are going to add up to? 100%. Why? Because that's your total amount. 100% means all of it. So if I take all my percentages and add them up, they should equal to 100%. And before we go on to the next problem, let's just make another couple comments here, especially about sig figs. There are no sig figs. That's because we're looking these numbers up on the periodic table. So why don't we just all agree right now that we will just always round these numbers to the nearest tenth of a percent, okay? And that way we'll pretty much stay out of trouble that way. If we only made it to the nearest percent, there might be cases where they wouldn't add up to 100%. They might add up to 99% or maybe 101%. But if we go to the nearest hundreds, we're going to be pretty much all the time at that 100% mark. So no sig figs. Let's just all agree, always make these to the nearest 10th percent. Okay, so let's look at the second question about silver carbonate. Let me scroll it up. Well, what did you notice I did to your silver carbonate? I didn't give you the formula. What do you think I want you to do? Why don't you figure out what the correct formula for silver carbonate is? Did you get this? I hope so. So now what do you think you need to do? You need to find the molar mass. So why don't you take a few minutes out and do that? If you need to pause it, go right ahead. This is, oops, that's not what I got. This is what I got right here. And so you know what we could do right now? Okay, we could probably go ahead and do this for all three terms, because what do I know? What is this 275.75? That is the, oops, okay, that is the whole. So now it's just a matter of putting everything on the top. So how many silvers do we have? Hopefully you said we have 2 silvers. So I would take 2 times 107.85. Don't forget we need to, oops, multiply this by, you already know the answer now, by 100%. So, well, all right, I'd have you calculate it, but you probably already saw the right answer. There it is. So what about the next one? I'll try not to give it away. What is, how many carbons do we have in this one? Well, hopefully you saw we have 12.01 grams. We have only 1 carbon, so we're not going to multiply it by anything. Multiply it by 100%. And what do you get here? See how you do on that one. Okay, did you get 4.4%? Not a very large amount, did you? And then finally, for oxygen, how many oxygens are there in silver carbonate? Did you get 3? So 3 times 16 times 100%. And what do we get there? Hopefully you got 17.4. So what is something that we should do to make sure that we didn't make a boo-boo anywhere? Hopefully you can add 78.2, 4.4, and 17.4. And what do you notice that we get when we add up those 3 terms? Yes, we get 100%. Good. Why don't you pause this, and I mean this, okay? Pause this and you practice copper 2 sulfate on your own. So pause this and then come back and see how you do. Well, the first thing you had to figure out is what is the correct formula for copper 2 sulfate, and then you could find the molar mass. So I found it is CuSO4. The charge is canceled out, so the molar mass is 159.62. And so then I found the part over the whole. This should be kind of come over here. There you go. And so I have 1 copper over 159.62, 1 sulfur at 32.07 over 159.62, and 4 oxygens. And these are the answers that I got. And notice what happens. When they add up, what do you get? You get 100%. So the next section, if you turn the page, we're talking about the evaluation of an ore. And this is actually a very realistic use of finding percent composition. Geologists would use that when they are given samples of ore and they want to know the percentage of a particular element in an ore. They will go through this. They'll take the molar mass of the ore and take the mass of just the element itself. They can use this to identify different ores and whatnot. So I have a little story for you. Just kind of saw some of these pictures. There's a place in Utah called the Kennecott Copper Mine. It is one of the largest copper mines, really, in the U.S., and it is huge. Here's a picture of it. Just a huge, huge, huge place. I had the chance to visit this when we had some extra time in Utah, in Salt Lake City, on our way home from a vacation, and we actually went to the Kennecott Copper Mine. You're probably saying, I don't doubt the fact that Mrs. Vandelay went to a copper mine. Sounds like something that she would do. And yes, it is something that I would do. And it was huge. So I remember standing on the edge of this and seeing, this pit that used to be like a mountain and now it's a pit. And these are roads with giant, giant trucks on them, although you can't even see the giant trucks because it is that big. And so the owner of the Kennecott Copper Mine is going to get out different ores, and probably the owner of the Kennecott Copper Mine wants to know, which one has the greatest amount of copper in it. Well, duh, why would he want to know that? Because that's where he's going to get the most amount of money. So concentrate your efforts on the ores that produce the greatest amount of copper instead of the ones that produce the least amount of copper. So what I want you to do is to determine the percent of copper of each species. All right, so the chalcocite, the chalcopyrite, the turquoise, the malachite, go ahead and find just the percent of copper in each one and then decide which one is going to be most profitable. So that is your assignment from for the rest of the bell. When you are done with it, oh, I'm sorry, you're not done yet. You thought you were done. Go back to your homework. So this is page 7 right here. Let me make it bigger. That's page, oops, other way around, this way. There we go. This is page 7. I want you to do, I believe this is page 8, 9, and 10. So if you can do that, that is your homework. I'll also put that on Google Classroom, that your homework is to do up to this page here. So hopefully you know what you're doing, and if you have any questions, hopefully I'll be around later on if you want to text or email me. So talk to you later. Have a good weekend.